In this video, our goal is to consider some application problems. And to get started, we want to read through this scenario. The J.R. Simplot Company is one of the world's largest privately held agricultural companies in North America. One of its major products is French fries that are sold primarily on the commercial market to customers such as McDonald's and Burger King. French fries have numerous quality attributes that are important to customers. One of these is dark ends, which are the dark colored ends that can result when the fries are cooked. Suppose a major customer will accept no more than 6% of the fries having dark ends. The customer called Simplot's company saying that a recent sample of 300 fries was tested from a shipment and 27 fries had dark ends. Well, assuming that the population of all fries from which that random sample was chosen, assuming it meets the 6% standard mark, what is the probability of getting a sample of 300 with 27 or more dark ends? Would like to comment on this result. How can this be used? How can the sample data be used to make informed decisions here? You see, let's assume that you and I work for the J.R. Simplot Company. So our analysis will begin as follows, that the only way we would have sent out this fries, or the 300 fries, the fries we sold, not necessarily 300. The 300 was just a sample. The 300 fries were taken from a larger shipment. The only reason why we forwarded that shipment to that customer must have been that we assumed that in the population of all fries that we're meeting the required standards. So we're going to assume in the beginning, dialing back, that the population proportion of all fries that have dark ends does not exceed, is at most 6%. That is what we're assuming, that our P is this. But then, based on what the customer is saying, this assumption has been called to question. Is it true or is it false? We're going to use the methods of inferential statistics to answer this question, to check if we can claim that this is either still true or false. So how do we do that in inferential statistics? We go to the population of all fries, and then we consider the sample. So consider the sample shipment. And in this sample shipment, what do we have? Our sample proportion of those of 300 out of 300. How many of them are dark ends? 27 of them are dark ends, which represents 9%. No wonder the customer is complaining, right? Because they said they want no more than 6%. So the question though is, this 9%, is it just due to chance? Does it present strong evidence that our initial assumption that the proportion of dark fries is no more than 6%, does it present significant evidence that that assumption is no longer valid? Or is this just a random sheer luck event and does not present statistically significant evidence against our assumption? Well, what we can do using the methods we have learned so far is to first check conditions for the use of the normal distribution as a model of the sampling distribution of the sample proportion, as a reasonable model for the sampling distribution of the sample proportion. that requires to check that. So we'll assume first that fries are independently drawn. Excuse me. That fries are independently drawn from the larger pool, are independently sampled. And then we need our success failure condition. So success is n times p. Our n in this case is the sample size, which is 300, multiplied by our p, which is assumed to be what? 0.06. Okay, and that will give us 18, which is greater than 10. We like that. What about the failure? The proportion of failure will be 1 minus p, so that'll be 300, 1 minus 0. Excuse me, sorry about that. So that will be 1 minus 0.06. So that will be, in this case, that will be 282, which is also greater than 10. Okay, and since both conditions are met, we can say that a normal distribution model is reasonable here. And if it's reasonable, the normal distribution is characterized by two parameters. So we need to find the mean of the sampling distribution of our p-hat. That will be p equals what? 0.06. And then we need the standard error too. So for the sampling distribution, standard deviation or standard error is p times 1 minus p all over n. So that will be 0.06 multiplied by 1 minus 0.06 all over n. Our n is 300, and that is 0.0137. So at this point, this observation that we got 27 out of 300, is it really unusual? If we want to consider if an event is unusual, we need to consider the probability that the sample proportion is equal to what? 27 out of 300. If 27 out of 300 is really far off from what? 0.06, that'll be somewhere here, 0.09. This is where 27 out of 300 is. If that is really far off from what? 0.06, then we can claim that this is unusual. So how far off though? Well, if 0.09 is far off, every other value above it is also even farther. So we're going to consider equal to 27 over 300 or even farther than that. So that will be probability of p at greater than or equal to 0.09, and that is the size of this probability. Using the normal distribution calculator in StatCrunch. So let me go to my calculator here. So what do we have? Let's see. So I'm going to keep this with me and do this. And the mean in this case is 0.06, and the standard error is 0.0137. And I'm interested in the area above 0.09. I like to compute that. So I have 0.0143, which represents about 1.43%. This number is less than what, 5%, which means that observing 27 out of 300, assuming that the population proportion is what, 6%, is highly unusual. This is really an unusual event if this assumption were true. Why am I observing something unusual? Well, a number of reasons. One is potentially that what I assumed might be false. And that is why I'm observing something very, very unusual. In fact, we're saying that the probability here is just 1.43%, which means what we have observed is extremely surprising if this is really true. And that calls into question the assumption that the population proportion is 6%. So that means that the management of the company, the management of the company has reason to question their initial assumption, the assumption that our P is at most what, 6%. And so that means we should reject the assumption and take corrective action and ask the customer how we can be of better service. Okay, let's look at the other side of the coin in this example. According to a study conducted by an organization, the proportion of Americans who were afraid to fly in 2006 was 0.10. A random sample of 1,300 Americans results in 143, indicating that they are afraid to fly. Explain why this is not necessarily evidence that the proportion of Americans who are afraid to fly has increased. Using the methods of statistics, we can answer this question and provide a suitable explanation. So, first of all, what did we know previously? We assumed that the proportion in the entire population who are afraid to fly in 2006 back then was 0.10. The question is this true or is this still false? Is it now false in our days in 2020, in this year? Okay, and our interest here then would be to go and collect our sample data evidence. So sample data collected, which will help us to either validate or refute the assumption, shows that out of 1,300 Americans, so sample size is 1,300, X equals 143 out of what, 1,300, indicated they were afraid to fly. And so that means that the sample proportion or point estimate, sample proportion P at is 143 out of 1,300, and that represents approximately 11% currently. So the question is, this 11%, how far is it from the initial assumption, which is what, 10%? Is it far enough from what, the 10%, that we should reject the 10%? Or is it reasonably close enough to 10% that we can simply say, yeah, this 11% is not too far off from 10%. So this still says that we should still align with what we got earlier in 2006. To do that, we need to check conditions again. Okay, we need to check conditions that those in the sample were randomly sampled. So the condition of independence, and because the sample is random, this condition is assumed to be met. Is met. Then what about the success proportion? That will be n times p. Our n in this case is 1,300 in the sample times the assumed proportion 0.10. So what would that be? That would be 130, which is greater than 10. We like that. That is greater than 10. Then what about failure?